Working with properties of mathematics. Which equation shows the multiplicative inverse of a number? So you're looking for multiplication and you're looking for inverse. Okay, this one came up to be 0. That's the 0 property. This one added the opposite, so that's the inverse, but it's adding. This one's multiplication, and it's times 1, so it gave you the identity of this letter. D would be the opposite of A, would be 1 over A, and it is multiplication, and it ended with the answer 1, so that one is your multiplicative inverse. Number 2, which of the following does not show the commutative property of addition? So again, we're looking for something that does not show the commutative property of addition. Oops, sorry. We have addition here, addition here. They just switched spots, so that's commutative. We have addition and addition. Even though this is multiplying, they kept it together and they just reversed it. So that's commutative. This one, also addition, addition, checks. And they just switched orders. So that's commutative also. But this one is of multiplication. So that's what we're looking for. Does not show commutative property of addition. Number 3, which equation shows the additive inverse of a number? So again, additive inverse. You want to add the opposite to get 0. Add. This one's adding, this one's adding, this one's multiplying, this one's adding. Okay, this one kept the identity. So that's identity property, so it can't be those two. If I'm adding the opposite and it gave me 0, inverse. Remember, that's the opposite. So we get 0 for your answer. So your answer is C. Number 4, simplify this expression. Okay, so if we have 5, I want to distribute my 5. Okay, if I distribute my 5, it would be 5 times y plus 5 times z. So let's see which one it could be. That one works. That's exactly what I wrote. This one doesn't have the 5. This one doesn't have the 5. And this one's all scrunched together. So the distributive property would be C. Number 5. Which of the following does not show commutative property? Commuting is when you have 2 and they switch orders. They can commute and it doesn't matter which way you add them or which way you multiply them. So 6 plus y equals y plus 6. That one is commutative because there's 2 and they just switched orders. Yx equals xy. Yeah, they just switched orders, so that one's good too because we're looking for does not. B, you have xy minus 4 equals xy. Well, they left off the minus 4 here. And then you have x plus y equals y plus x. Again, same variables, just switched order. So your answer would be B. Number 6. Which property is used for the following expression? So we're starting out with a number outside the parentheses and numbers inside the parentheses. But over here we have no parentheses. We kept our addition sign. So what do you think happened? 7 distributed itself. So 7 times 3 is 21 plus 7 times 2 is 14. So it became the distributive property. Number 7. Which property of addition is used for the following? So we have x plus 2 plus 5. We have, let's say x, 8 plus 2 plus 5, 8 plus 2 plus 5. So the order didn't change, but the parentheses changed. And when you add the parentheses, it's kind of associating. 2 is associating with 8, but over here, 2 is associating with 5. So it would be the associative property. Number 8, which property is used in the following? So we have x times 7 plus 4 in parentheses. So that's what we're really going to look at here. 9 times 7, 9 plus 9 times 4. So we could also have written without this multiplication sign in there. That might help you a little bit. So what it's saying is, let's do 9 times 7 plus 9 times 4. And what property is that? When 9 distributes itself to the other numbers. Number 9, which property is used in the following expression? A times B times C, A times B times C. Again, we have parentheses, and we know it's not addition. Not addition. Did anything distribute to each other? It didn't even distribute, so that can't be it. So associative property of multiplication. So again, B associated with A here. Over here, B associated with C over here. So your answer is C. Number 10, which equation shows the identity property of multiplication? So we're looking for multiplication and identity. We want to keep the identity. So A plus B plus 9 equals A plus B plus 9. So this one has parentheses in it. And 9, and it kind of refers to everything. That would be your associative commutative property. So that's not it. A times 1 equals, A times 1 equals A. It kept the identity of the variable, and it was multiplication. Over here at B, we have 1, 2, 3 A's. So we can also write it as 3 times A, or 3A. Over here, A distributed itself. So which one kept the identity of multiplication? think number C did, or letter C did. Okay, let's look at the back. Which expression is equivalent to y times 48? And I would just tell you, let's see, y times 40 plus 8. Well, y times 4 times 8. Y times 40 plus y times 8. Y times 4 plus 8. Okay, I would start plugging in some numbers and see what you get. Process of elimination. Plug in, say, 1 for y or 2 for y. Work them out and see which one gives you the same one. Same thing with this one. Which expression is equivalent to this? Okay, you're going to have to work them out and see which one is equivalent. Which expression is equivalent to 30 divided by 3 plus x? Okay, I've plugged some numbers in and try them out. Number 9, Leon wrote expression that is equivalent to. So we're always looking for something that's equivalent to this. This is something that you need to problem solve and make sure that you're working the problems right and just see if you get the same answer. Okay, she wrote the expression here. Show the amount of money 5 friends paid for snacks at a baseball game. Which expression is equivalent to the one Shay wrote? Okay, so that's what we're looking for. If you have questions, come in early to class. But I expect you to have the front page completed.